When you're sitting down to write a program, before you write any code at all, always ask yourself this question: how am I going to debug my program? Because if you don't ask that question, and you've compiled your code, you've gotten past all the syntax errors, you're not going to know how to verify whether it works. And this is a critical question to ask. And in particular, when you're dealing with signal processing systems, you need to look at this very carefully, because with signal processing systems, the result is just a stream of numbers. It's not like a lot of the other programs you've written in the past where they have some obvious result that you can tell is correct. So let's talk about the actual equation that you're implementing. So if we look at the sum of products that you're trying to put together, with the FIR filter we have some number of B coefficients. In this case, we go from 0 through n. And if we look at this equation, what this really means is we're going to say take the coefficient that's at index 0 and multiply it times the most recent data. And then going all the way through, we're going to take the coefficient that's at the later index, n, and multiply it times our oldest data. It's the oldest data because with this minus n, we're going backwards in time. With that in mind, let's go back and look at our C code. Now in our C code, it's pretty simple. We have this Q read element at, and remember that when I is 0, that is the oldest element in the queue. And then we have some coefficients that we're going to multiply by. Now, this code has some bugs in it. Some of you might recognize that immediately. That's okay. We're going to work through several bugs together in this video. The code that I'm showing you here is some code that I just threw together about 10 minutes ago. It's simple. It doesn't have any comments in it to keep it small, so it'll fit on the screen and whatnot. My regular code is much more verbosely commented. Let's look at our run test. So I have this currently coded up as what I call a sanity test. So I always like to print a message at the top so that when I go back and look at the output, I can find the top very quickly. I initialize my filter, which basically initializes the queues and fills them with zeros. Then I write a 0 to my queue and run the FIR filter, printing the result. And then I put a bunch more zeros, at 60 in this case, while printing out the result. Now why do this? This seems kind of silly because basically you're saying, well, the X queue will always have zeros in it. Well, the nice thing is it's really easy to know if this is right, because if this is true, then the FIR filter should always output 0. If it doesn't, then you've got something fundamentally wrong. Your queue may not be working properly, maybe your math is wrong. You know, it'll vary depending on the circumstances. But it's an easy test to do, and it's cheap, so it's worth doing. So I'm going to go ahead and run the program, and we'll look and see what the output is. So here's the output of the program in the console, and we can see it's printing out zeros. And if we scroll all the way through, we'll see, aha, it's always putting out a 0. So that means I passed a sanity test. It means my queues could be, you know, there's no fundamental problems that I'm seeing with my queue. This doesn't mean that there aren't bugs, and you may still discover them. But this is a simple, easy test that'll often flush out, you know, simple brain-dead bugs right at the start. Okay, fine. Now the next question is, well, again, asking myself this question, how am I going to debug my code? The only thing that's really maybe a little bit difficult to get right here is aligning the right coefficient with the right element of data. So we'd like to be able to verify that. If you're careful about how you choose your coefficients, you can do that. Now you don't have to use the coefficients that you generated in MATLAB to figure out if you've got this right. In fact, I didn't. What I did is I used a set of coefficients that are a lot easier to see. My coefficients are just the numbers 1 through 50. The nice thing about that is I should be able to tell whether or not I'm getting to those coefficients in the right order. That is, lining those coefficients with the individual elements in the queue. The way I'm going to do that is I'm going to change this first write so that it writes in a single 1. And the single 1 will then march all the way through the queue, because I'm going to put a 1 in, and then after that I'm just going to pile zeros behind it. And that'll just push the 1 all the way across the FIFO. I'm sorry, the queue. Now, what should the result be? Well, since there's only a single 1 in the queue, that means that there's only one non-zero multiplication that'll ever happen in the FIR filter. You're going to do 50, multiply accumulates, but only one of those 50 values is non-zero. So everything else will zero out. That means that when I run this code, what I should see are the coefficients, okay, as the one moves across. You know, when it starts out, I might see this one. As the one moves across, say when I get in the middle, I'll see 28. And as that one moves to the end, I'll see 50. And then when the one falls off the end, I should get zeros. So again, this is a very simple test by careful use of coefficients to see if I've got my multiplication aligned correctly. So let's go ahead and run that program. All right, you can see that I've run the program. And here at the top I have filter run test, and there's my coefficient. Oh, it seems to be a problem. All I get are ones. And then it runs out of zeros. Why do I only get ones? Well, let's go back and look at my code. Oh, I just have a zero there. So I'm always multiplying by coefficient 1, or coefficient 0. What's in coefficient 0? 1. Oh, okay. All right. Now, that's kind of an obvious mistake. Let's fix that and put the index I in there. And let's go ahead and run that program and see what that does, because now I'll get the coefficients indexed by I. Okay, I've run the program again. Now let's look. I've got filter run test, and I've got, okay, look, I'm getting all of my coefficients, because now I'm indexing with I. So 15, all the way through till I get towards the end, and then the one falls off, and now the Q only has zeros in it. Okay. But I still don't have this quite right, because I'm multiplying the oldest with the B coefficient that's at the largest index, and that's backwards. That's not what I need to do. Remember, if we look at the, if we review the equation, we can see it's the other way around. The newest one gets the zeros, and the old, okay, let's fix that. So that means we need to sort of change our addressing. So here we would do for, let's see, where's my, so we would use FIR coef count so that it's at 50, so that when I subtract I, then that will flip things, right? Because when I is a 0, then coefficient count 50 minus I will be, so that would be 50. So when this is 0, this is 50. When this is 50, this would be 0. Okay, let's try that. Okay, I've run the test again, and now, okay, this is better. Now the coefficients are in the other order, but I'm missing one. So let's go back and look. Okay, so when I is 0, for coefficient minus I would be 50. Oh, well, that's a problem because C is 0 indexed, and if I have an array that contains 50 things, I can only go 0 through 49. So I need to subtract 1. This is sort of a standard C idiom thing. So let's try that and then run our program. After running the program with that fix, now things are looking pretty good. The coefficients are now in the right order. Okay. The oldest data, which is, you know, when I is equal to 0, is getting the coefficient that's at the 0th location. So that looks pretty good. Okay. So what's another test we can do? Because now we verified that the coefficient is aligned properly with my data. That's great. But it'd still be kind of nice to know if my math was complete. So we could do one more test. What I could do is just always put ones in. Now if I put ones in, then what I'll see is it'll start out with the first one, which means I'll get that first coefficient multiplication, which would be a 1. Then after that there'll be 2 ones, and so I'll get 2 multiplies that are non-zero. So that means I should add the 1 and the 2 and get a 3 and so forth all the way up. And so that means that I should see these things sum up. So in order to help me do that a little bit, I just went to my spreadsheet because this was trivial, and I had it sum up 1 through 50 for me, and that number is 1275. So with this particular program, once the queue is completely filled with ones and stays that way, then the output of the FIR filter would max out at that 1275 value, if I've done it right. So let's run that program and see what it does. Okay, I'm running the program again, and sure enough, it's doing what I thought. So when that first one is in there, I get that 1. And then the next coefficient, if you remember, is 2. So that gets added, that's 3. The next coefficient is 3, so that'd be 6. So that's a full summation. And let's see, do we max out what we're supposed to max out? And indeed we do. So through all these tests, I have now verified that 1, my coefficients are getting aligned properly with my data, and 2, the math is getting computed correctly. At this point, you can just plug in your original coefficients, the ones that you actually computed in MATLAB, and do similar sorts of tests. It's always good to double check after you paste things in, because generally you should assume anytime you modify the code you may have introduced an error. But it would be easy to do. You could do the test of the one, a single one marching through the queue that would show you the individual coefficients. You could compute the sum of all the coefficients and see if it adds up properly. And at that point, you're pretty confident that your FIR filter works. And you did that because you were very careful about how you went through step by step, verifying that the math is done and the coefficients are aligned with the data properly. This is far more productive than trying to throw everything together and hope it works, or to stare at it and hope you'll find the error, because believe me, you probably won't. And if you did, well, good for you, but don't expect it to happen very often. So hopefully you'll find this, video helpful in terms of finding out ways to debug your FIR filter code. And in general, I just want to reiterate, the most important thing to consider when you're writing code is think about how you're going to debug it first. Look at the problem. Look at the pieces that are hardest to get right, and come up with verification strategies for that.